Hi, in this video we are going to see simplification of grammar. So simplification of the grammar can be done in three steps. The first one is removal of useless productions, then which means non-reachable productions or non-derivable production. Non-reachable in the sense it will be never, that means the non-terminal will be never reached from start symbol, and non-derivable in the sense that particular non-terminal will never produce terminals. So these are the two things specified as useless production, as they will not contribute to the language derivation. Next one is removal of unit production in the sense non-terminal derives single non-terminal. So single non-terminal derives single non-terminal is called as unit production. And last one is null production. So non-terminal derives null. This is called as null productions. So removing all these three things from a given grammar, it is called as simplification of the grammar, where it helps in optimization of the utilization of the grammar. So the first one is removal of useless production for the taken grammar. So how it can be done is, first we have to check whether it is giving any non-derivable grammars. Non-derivable grammar in the sense we have to check the non-terminals. So how many non-terminals are there here? 1, 2, 3, 4 non-terminals are there. In these 4 non-terminals which are not producing. So since S is a start symbol, this rule is not applicable to the start symbol alone. So though it is not producing a terminal, still it exists. Whereas A is producing terminal, so it is derivable. Then B is not producing any terminal, so it is non-derivable. Then again C is also not producing any terminal, it is also non-derivable. So using these, having these two productions in the grammar will not help us in deriving a language, so it can be removed. So once this is removed, so wherever B and C are available, so those productions can also be removed. So C is not available in the right hand side of the productions, whereas B is available here, so which is also removed. So only the existing is S derives AB S or AB A, and A derives CD. And since A is reachable, so from the start symbol A can be used, right? So this is also reachable. So this is the simplified grammar after removing of the useless productions. The next one is removal of unit production. Removal of unit production in the sense, so non-terminal, single non-terminal derives single non-terminal. So the non-terminal is producing only one non-terminal. So we have almost 3 non-terminals from the given example. So what we have to do is, so how it can be removed in the sense, the equivalent production has to be substituted to the in the right hand side of the non-terminal, single non-terminal location. So that means that here D derives B is there, so which will be substituted in the place of the D in the right hand side, so that this production will be removed. So what will be the answer if it is been producing? Means S derives AB, A derives E, then B derives C, then C derives, in the place of D what will come? B will come, right? Then again whatever remaining will be there. So in the same procedure, if we are going to implement, means what will happen? So in the place of C, C's productions will be substituted, and in the place of E, E's production will be substituted, so that these two will be removed. Now S derives AB, A derives, so in the place of E what is substituted? A is substituted, and in the place of B what is substituted? Small b is substituted. So this is the simplified grammar after unit production. That means we have removed the unit production, but still we have to check whether it is reachable and generatable. So what is this? B derives B, so it is having a terminal. A derives A, it is also having a terminal, and then S derives AB, both are reachable from the start symbol. Now the third one is removal of unit production. That means a production which produces null is called as null production. So that has to be removed from the given grammar. So here we have A derives null, C derives null. So considering from the down. So what is the first? I mean, we are taking is C derives null. So on implementing C derives null, that is when we want to remove it. So what is the procedure is that means if at all in the production the right hand side, if null wherever is applicable is substituted, the resultant production should be added to the same production. That means, say for example, the first one, S derives AB AC, the first production I have taken it as it is. So here then what is the thing we have to do? C derives null. So if at all null is substituted in this production, what will be added to this particular production? In the S production, A, B, A will be added. Right? Then what is the next thing we have? A derives BC, whereas what will be added in the place of C? Suppose null is substituted, what it will be giving us the answer? B. The next one, B derives B. Null should not be included here because we have started implementing null in the upper cases. So here we are not having more than that. So it is C derives D null, then D derives D as it is. So this is after removing of the null production, C derives null. Now next one is B derives null. So while doing B derives null, what to be done here? The same to be taken here. So S derives AB, AC, AB, A, and wherever B is there, so both production B is there. So if at all null is substituted, what will happen? A null AC. Then here also again what will happen? When B is null, A. Right? Again, A derives BC, B. Then what will happen? In the place of C, right, null is substituted. What it will be producing? B will be produced. Sorry, in the place of B, null is produced. What it will be producing? C will be produced. And we have a special case here that to be considered. So what it is means, suppose if B is also null here and C is also null, what it will be producing us? Yes, you're correct, null will be produced. So that it is giving rise to the new condition A derives null. Now after that what is there? Nothing is there. So same thing, B derives B, then C derives D, then D derives D. Right? Now for this particular grammar, again what we are going to do? We are going to substitute A derives null. Right? So on doing so, what it will happen? In the same production, I will keep the production for your reference. So what we have to do? Same thing only again. S derives AB, AC, ABA, AAC, then AC. In the place of A, if null is substituted, what it will be giving us? BAC. Then in the place of ABA, in the place of A when substituted, BA. Then again in this production it is AC, and in this production it is A. Right? Now A derives, here it is BC, BC, null has been removed because we have substituted. Then again the remaining productions, B derives B, C derives D, then D derives D. Now this is the answer for removal of null production. After null production removal. If you ask that this is a simplified grammar, no. we have to simplify the grammar. Why? Because it is having unit production, and then it is also, we have to check whether it is non-reachable and non-generatable, right? So in that case, what happens here, we have to specify as yes derives, so we can check for it. So unit production can be removed, so in the place of D, right, D can be substituted, the place of AC, again A value can be substituted, then again C value can be substituted there directly. So the grammar will be like S derives ABAC, then ABA, AAC, then AA, BAC, then BA, then again it is AC, A. Right? Now in the place of A derives BC, then B is a unit production, B's production is B, and then C's production is D here actually, but first we have to suppose if you are implementing this, so this will be the small d, right? So we can directly substitute small d here, then B derives D, right, and C derives D. Fine. Now this is the simplified grammar. So A is having a terminal, B is having terminal, C is having terminal, so all the non-terminals are generative, and then again it is also reachable A, B, C from the starting point. So this is the simplified grammar. Right? Thank you. Now, how to answer the question whenever they are asking you to specify simplification of a given grammar. So you have to write definitions for all these things, right? That means simplification of the grammar consists of 3 steps. Removal of useless production, and useless production in the sense they are non-reachable and non-derivable. You can also write as non-generative, right? This is also specified as non-generative, right? And then removal of unit production and the definition for the unit production, removal of null production, definition of the null production. So this is procedure, theory part, right? So when you perform, then you have to explain how it is being simplified, and then only you have to give the answer, right? So this is the procedure to be adapted. Fine. Thank you.